Let's learn in this video about Azure Key Vault, the KMS key management system solution for Microsoft Azure Cloud that could be used by the Azure PaaS services or customer applications in order to securely save secrets and certificates. Those secrets could be like database passwords, connection strings, API tokens, private certificates, and so on. Let's get started. Azure Key Vault is a very important service within the Azure cloud because that's going to be the central location where customers could save securely their sensitive data that will be encrypted using Azure provided keys. So that's our Azure Key Vault. Within the Azure Key Vault, we can store different types of objects or of data. So typically the most used, let's say, that's the secrets. So we can save secrets. Those secrets could be something like database password, for example, or it could be something like an API token. And then we can use it also in order to store certificates. So we have a second type of object within Azure Key Vault that is the certificates. So those certificates typically could be like the TLS certificates, or anything that could be a private certificate, something that you want to keep for your application and you don't want it to be exposed publicly and you want it to be encrypted. Okay. And also we have a third type of object that is the keys. So the keys here would be actually the encryption keys that would be used in order to encrypt those secrets. So you can rely on the Azure Key Vault or the Azure provided encryption keys to encrypt those secrets, but you can also provide your own encryption keys here to encrypt those secrets or some other data that you want to encrypt it. So keys here are different than the user settings keys or the application settings keys. Okay, if you want to use those preferences like a web color, for example, or some feature flags, then Azure Key Vault is not the right tool for that. Azure Key Vault is for securing sensitive data. For those other use cases, you might consider using another Azure service like the Azure App Configuration. Great, so now we have this Azure Key Vault actually. So those secrets are sensitive data. Typically, we have two models for defining this data. Either it's the project teams who will go to create those secrets, who will own that Azure Key Vault themselves, or in some other models we have the cloud administrators or some admin who will go to create that Azure Key Vault, define the secrets and the certificates. And that's going to be our cloud or Azure administrator. That admin actually who will go to create the Key Vault and let's say who will do the admin part of that Key Vault. So those are typically a group of users. They might be 2 or 3 users from our Azure AD tenant. Okay, and in order to get access to the Key Vault, of course, they will use their own identity, their human user identity, and they will need some airbag roles to be able to manage those different roles. Okay, so the roles they will need there are going to be the Key Vault administrator. And as part of the management, what they will do also is that they will define the policies to apply to the Key Vault. They will also apply, for example, the nearing expiration for the certificates, the auto rotation of these certificates, the different versions of the secrets, the backup of the Key Vault or of the secrets inside, and so on. So that's the responsibility of this team. Now, the second entity that will go to use this Key Vault is the consumer. Okay, so this is the publisher or the administrator. Then we would have the consumer, and that would be, of course, our application. So those Key Vaults, actually, those secrets could be also used by Azure PaaS services. Okay, something like the Azure Storage or the VMs or the web apps. They could go to reference those secrets and those certificates from here. And in that case, Azure Key Vault will be entirely managed by Azure for you. But for the case for our applications, for the customer applications, those will need to get explicit access to the Key Vault, and that Key Vault would be customer managed. Okay, so let's say here I would have my client application. So this could be any type of app, and it could have access to the Azure Key Vault. Thanks to using the client SDK for Azure Key Vault, we have clients implemented in C#, in Python, in Java, in JavaScript, and many more. Okay, so that client app, for any reason, it would need access to that database password, for example, in order to retrieve the password to connect to an external database. Then, to get this access here, my client application would need again some airbag roles. So, and if it is an application that is hosted on Azure, then it can use the Azure Managed Identity. Otherwise, if it's outside of the Azure boundary, like on-premise, then in that case, it would use the service principal, the SPN. But let's assume here that it will be using the Managed Identity within Azure. And within that managed identity, we'll go to define the right airbag roles needed by that application. So from here, with managed identity, we can assign specific airbag roles. So the roles that will be needed here will be actually not the Key Vault administrator, because that gives access to the management of the Key Vault, but here we need only access to the data plane for the Key Vault. It means I will give it access like the Key Vault secrets user, for example. And with this role, it could list and retrieve the secrets with their contents, okay? But it will not be able to delete the Key Vault, for example, or define policies on that Key Vault, or add other managed identities, for example. That's going to be the only responsibility of the Key Vault administrator. So using this identity, my client app would be able to connect to the Key Vault and retrieve this data. So here, this role Key Vault secrets user is only for getting the secrets. If I want to get the certificates, again, I would have the right airbag role for that, and the same for the keys. So for each entity, I would have the right roles defined for each one. And this model actually is what is recommended in Azure, to have the Azure Key Vault owned only by one single application. But in reality, there are some other use cases where, for example, we have hundreds and dozens of client applications, and we have some secrets that will be shared among the different Azure Key Vault instances. So in this case, we have actually two models. Either we define one Key Vault, we still define one Key Vault per client app, and then put all the shared Key Vault secrets within another Key Vault shared instance. Okay, in that case, each app would consume actually two Key Vaults. One, the shared Key Vault that contains the shared data, and the second Key Vault would be the one that contains data available only for that client application. That's model one. Model two is to leverage the Azure Key Vault airbag mode. We have the access policy mode or the airbag mode. So if we choose the access policy, it means that the access policy will be defined for all the secrets inside the Key Vault. We don't make the difference between secret 1 or secret 2. It will be inherited by all the objects there. However, with the airbag mode, what we can do is that we can define airbag roles at the scope of these secrets or these certificates. It means I can give to the application number 1 the right role. Let's say this is my app number 1. I can give it the right access role to only the first password, for example. So it means here this arrow will not stop here. It will go actually like this. I will give it access to here, but it will not get access to this one. Okay. And also with that, I can also give it access to the certificate number 1, but not to the certificate number 2. It will not be able to access this, of course, if I define those right airbag roles on the objects themselves. So for each object here, I will be able to define airbag at this level. Okay. So this means at the airbag here, I would give access to this application through this managed identity. Okay. Great. So now this means that here, if I have client application number 1 consuming those specific secrets and certificates, I might have also a client application number 2 that will consume another set of secrets and certificates. So let's say here I would have client app number 2. Okay, again it will use another managed identity. Its own managed identity is also recommended to work like that. So each application will own its managed identity, and that managed identity actually will go to use another airbag role. So here we would define another set of airbag role. So that's gonna be again the key vault secrets user, for example. But in this case, this one is gonna be for the secret number 2, for example. Let's say S2, and this one for S1, for example. Okay, and that will give it access to those specific secrets. So let's say here it will get access to this certificate, and also it will get access to the second secret. Okay, so that way we can define multiple applications that share one single Azure Key Vault instance, but for each application it will have access to the only objects it should have access to. Okay, however, here we still have this management plane will still be managed by the Azure Key Vault administrator, who will be the only one that can configure the management of Azure Key Vault. So this is somehow, let's say, multi-tenancy model, where the multi-tenancy will be applied only for the consumer applications, but not for the management plane of Key Vault. Now, as part of that management plane, earlier we have talked about the Azure policies. Okay, so in Key Vault, we can define some policies that will define, for example, the expiration date for the secrets or for the certificates, the auto rotation for these certificates, and so on. And we can define events that will go to be triggered when we near the expiration of the certificates, like 3 days before or 7 days before, and that will go to trigger the auto rotation automatically, for example. Then, as part of these policies, we can define, for example, to say I should always enable soft delete and disable purging the data for my Key Vault objects right there. And those are actually one of the tools we use in order to secure the Key Vault and to help for the backup of Key Vault. So for that, here we have those features called soft delete, and also purging the data purge. Okay, so we can define a policy for enabling the soft delete and disabling the purge. So we can also define a value between 7 days to 90 days, so that if I accidentally deleted a password, for example, or deleted a secret, I can still retrieve it after that specified or during that specified period of time. And for the backup here, actually the Azure Key Vault is, let's say, a regional resource. It means it's available in one single Azure region, but Azure will create a replica and will replicate that Key Vault with those different objects in another Azure region that is the paired region. Okay, so the backup, we have actually a copy in the paired region. We know that for each Azure region, we have another secondary region or a paired region. For West Europe, for example, the paired region is North Europe. So Azure will go to replicate that data in that paired region. And in the case where I lose that primary region, Azure will route the traffic to that secondary region, and that will be transparent, completely transparent for the application. The application will still use or consume one single API or one single URL, because this Key Vault actually will be available on a public endpoint or a private endpoint, as we'll discuss here. Okay, so it does have an endpoint. Okay, that endpoint is of type of something like Vault, Azure Key Vault.com, something like that. So Azure will go to replicate that data, and once we get back that primary region that will be restored, Azure will go to reroute again the traffic to that primary Key Vault instance. Great, but when we read data from that paired region, those data, actually, those secrets and certificates will be available on read-only mode. Okay, we cannot change those certificates or add other versions of the secrets and so on. It's available on read-only mode. Now the question is, how much does this cost? So actually Azure Key Vault itself is free. So if I create the instance itself, it would be free. Okay. Then, however, the cost model will be per request. Okay. So each time I send a request to retrieve a secret or a certificate, that will cost me money. Okay, that's what will cost in this case. And to give you an estimation, of course, this might change depending on the day you are watching this video. So go to always check the Azure documentation for the latest updates. For today, as per I'm recording this video, it will cost you like $3 per where 1 million request. Okay, 1 million requests. I mean here a request is when I'm requesting a password, that's a request. When I'm requesting password and the API token, that is counted as 2 requests. Okay. However, for other operations like auto-rotating the certificate, that will also cost you money. So that the cost is actually per request and also per operation. Auto-rotating the certificate is an operation, defining another version, and so on. Another thing here for helping you to easily manage the Key Vault and secure it is actually the versions. So with the secret, when we define a secret called database password, this database password might change over the time. So in best practice, I would define a new password each 30 days for each 30 days or each 3 months, for example. So, and at the same time, I want to keep the history about the previous versions so that I can restore back to use these previous versions in case where I need it. Okay, so Azure Key Vault will define the notion of the concept of versioning for all of these objects. So for the secret, for example, I can define database password with a value and then define a start and end date for that password, and then define another password that will be valid for the next 3 months, the next 3 months, and so on. And we can go up to 500 versions per object. Another thing I would add here is related to the backup. So we have said that the Azure will go to backup the Key Vault into a paired version. And as a user, you might not be interested in that paired version. So what you can do in this case is that you can create your own backup. So you go to export those secret certificates and keys and then save them in your own data center or on your own environment, and then you can restore them back to another Key Vault instance. And then another aspect for Azure Key Vault is the logging and metrics. Okay, so for logging and metrics, actually we can use Azure Log Analytics and go to enable, and within the diagnostic settings pane in Azure, inside the Azure portal, we can actually request to get some data, some logs, and some metrics about the secrets. So we can view, for example, the number of requests for each secrets, the number of requests for each certificate, who requested that data, what is its IP address, and the date, time, and so on. And we can view also the operations that have been done for the Key Vault, like adding new secrets, auto-rotating the certificates, and so on.